The second part of 11.1 is about combinations. Now, if we backtrack for a second, when we had permutations, the order matters. So if you had 10 runners in a race, and we have first, second, and third place, it matters what order those runners finish because it matters who wins. It matters who gets second. If we have a combination, order does not matter. So I guess an example of a combination, 10 runners in a race, and the first 3 advance to the next round or advance to the championship. So it doesn't necessarily matter who wins that race because the first 3 runners advance anyway. Now with permutations, we had that formula that we used where we had n factorial over n minus r factorial. But we could kind of avoid using that just with that fundamental counting principle. But with combinations, we actually do need a formula. And our combination formula looks like this. So we have the capital C, subscript n before, and a subscript r behind. So the number of combinations is n factorial over r factorial times n minus r factorial. And just like before with our permutations, n is the number of items. The number of items in a set. And r is the number we are selecting. How many selected? So if you look at this example here, if we have 10 runners and the first 3 advance to the championship, n would be our 10 runners. Okay, we have 10 runners, so n is 10. And r, how many are selected? That would be 3 because the first 3 advance. So we can just kind of use this as example 4a with combinations using our combination formula. How many ways can the top 3 runners advance to the championship race? If there are 10 racing. Okay. So again, order doesn't matter here. It doesn't matter what order these runners finish. We just know the top 3 are going to advance. So we use our combinations formula. In our combinations formula, we already kind of pointed out that n is 10 because that's how many runners we have. And r is going to be 3 because we have 3 runners that are advancing. So we plug this into our formula. N factorial is on the top. So 10 factorial over r factorial. R again was 3 times 10 minus 3 factorial. And we can type this in on our calculators, just like we did with the permutations. We just have to be careful with how we type this in our calculators because that 3 factorial times, this is really 7 factorial, all is on the bottom of our fraction. So make sure when we type this in, we have 10 factorial divided by parentheses 3 factorial times, and then again, I'm just going to write this as 7 factorial. There's 120 ways, 120 different groups of people that could advance to that championship race if we only have 3 that advance.